Hi everybody, today we are going to learn to graph from a new form called standard form. So the standard form of a linear equation looks a little different than the slope-intercept form. So standard form will always look like this, ax plus by equals c. So a few things to point out that are very specific for standard form. A, b, and c are all going to be integers, meaning non-fractions, and a will always be positive. B and C might be negative, but A will always be positive. So you'll notice that this does look quite different from our slope-intercept form of y equals mx plus b. So how do we graph something that looks like this? So one way you can graph equations that are in standard form is actually by rewriting it into slope-intercept form, which is y equals mx plus b. The reason why we would do this is because graphing from slope-intercept form is super quick and easy. So our goal is to make this look like this. So you might notice that we do need to solve for y. So let's look at this first example together. So we have 2x plus y equals 3. So remember, our goal is for our equation to say y equals. Therefore, I need to move anything else that's on the same side as y. So I need to move 2x using an inverse operation. I'm going to treat it as a single term because it's already grouped together. So the way I move it is by doing the opposite. The opposite of positive 2x is negative 2x. So I'm going to subtract 2x on both sides of my equal sign. And what I have left is y equals, so that was our goal. Now, there's a reason why I kind of wrote this offsetted like this. It's because you cannot combine terms with variables and constants, which are terms without variables. So how do we write 3 minus 2x? We can write it as 3 minus 2x, but if you look at our slope-intercept form, you can see that we're always going to want to write our x term first. So I'm going to write this first, so negative 2x, and then our constant second, which is a positive 3. So now that it's in slope-intercept form, we know how to graph it. We can see that our slope is negative 2 over 1, telling us to move down to right 1 between coordinates. And I can see that my y-intercept is going to fall at 0, 3. So start with the y-intercept and follow your slope. Down to right 1, down to right 1, down to right 1, or opposite, up to left 1. And there you go. Let's try another one together. Here we have 6x minus 3y equals 3. And we are going to want to rewrite it in slope-intercept form. Remember, y equals mx plus b. So we can graph it easily. So I notice that I have to move the 6x term, and then I'm going to need to get rid of that negative 3. But let's start by moving 6x by doing the opposite and subtracting it from both sides. So be careful here. While the 6x term is gone, this negative belongs to the 3y. So we have negative 3y left. And then to match slope-intercept form, I'm going to write my x term first. So negative 6x, and then we have a positive 3. Now, for us to get rid of this negative 3, we're going to do the inverse of multiplication, which is division. So we're going to divide both sides by negative 3. But notice, when we do that, we need to divide the entire side by negative 3. So here we have 1y equals. So let's start by dividing just this first term. So we're going to do negative 6x divided by negative 3, which becomes positive 2x. And then we're going to divide this term by negative 3. 3 divided by negative 3 is negative 1. So we have 2x minus 1. So this should be something that we are able to graph. We can see that our slope is 2 over 1, meaning up to right 1. And we can see that our y-intercept is at 0, negative 1. So we start at the intercept and follow the slope. Up to right 1, up to right 1, or down to left 1 to move backwards. Connect your dots and you are all done. Okay, this last example is a challenge problem, so we're going to give it a try. So we have x minus 2y equals 3. So remember, our goal is to isolate y, so it's in slope-intercept form, so it's easy for us to graph. So just like the last problem, I'm going to start by moving my x term. I'm going to subtract 1x from both sides. These cancel out, and I'm left with negative 2 times y equals negative x plus 3. So remember, we're going to write it in the order to match our slope-intercept form, so we're going to write our x term first. From there, to remove the negative 2, we do the inverse operation, which is to divide, and we're going to divide both sides by negative 2, leaving us with 1y equals, so let's divide these each separately. This is a negative 1x, and this is a negative 2. So if I have negative 1 divided by negative 2, well, my negatives are going to cancel out, but 2 doesn't go into 1 evenly, so it's just a fraction, 1/2 x. I have negative 1 over negative 2, which becomes positive 1/2. Now here I have positive 3 over negative 2. So that's another fraction, and it becomes negative 3/2, or 3 over 2. So from here, we can graph. Let's start by looking at our slope, which is 1 over 2, telling us to move up 1, right 2. And then I can see that our y-intercept is going to be 0, negative 3/2. So to graph these, we are going to need to estimate a little bit to find where halves are. So we're just going to go in between the correct two integers. So let's start by plotting this point. I'm actually going to count by halves. So here we have 3 halves. So if I start at 0, here's negative 1/2, here's negative 2/2, here's roughly negative 3/2. So we're going to start right here. So do your best to go in between negative 1 and negative 2. Or you can convert it to a decimal if it helps, negative 1.5. Now, to follow our slope, up 1, right 2, up 1 would lead me to another halfway point. So I'm going to go up 1, right 2, and that's where my next point will fall. And then I'm going to do it again. Up 1, right 2. So we're kind of floating in between whole numbers right now. Let's go backwards. Down 1, left 2. Down 1, left 2. So those are where my next 2 points will fall. And now we can connect the dots and we should get a nice straight line. So just remember, when you go to divide, when you're rewriting, if you have something that doesn't divide evenly to the number, that means you're just going to have a fraction. And we can graph fraction coordinates, however, we just are going to need to estimate where that is on our graph. All right, go ahead and pause the video, please, and give these 3 problems a try. Rewrite them in slope-intercept form and then try to graph them. Part C is a challenge problem. So if that one's tricky, it's okay, but please give it a try. We'll check our answers in about 10 seconds. Okay, let's start by looking at parts A and B. So when you're rewriting in slope-intercept form, you should end up with y equals negative 4x plus 1. So here I can see that my y-intercept is at 0, 1, and my slope is negative 4 over 1. So down 4, right 1, or up 4, left 1. For part B, check your 2 steps here. Be careful with this step. We are dividing both sides by negative 2. Negative 2 divided by negative 2 becomes positive 1, so we have positive 1x. 4 divided by negative 2 becomes negative 2. So my y-intercept is at 0, negative 2, and my slope is 1 over 1. Up 1, right 1, up 1, right 1. And for part C, this was the challenge problem. Subtract 3x from both sides, divide both sides by 2. But look, 2 doesn't divide evenly into negative 3, so we have a fraction, negative 3/2 x. And then 1 is also not divisible by 2, so we have another fraction. So I can see that my y-intercept is right here. It's at 0, 1/2, so I had to estimate where 1/2 was. And then my slope tells us to go down 3, right 2. Down 3, right 2, and you have to estimate. Or up 3, left 2. All right, that is all for today's lesson. Thank you so much for watching.